we are back with our second lesson from the unit circle, and again we are talking about our angles, so it's all about angles day 2 or more about angles. Today's topics are going to be the coterminal and reference angles. We're only looking at those two things. We will do some sketching again to help us figure out our coterminals and our reference angles, and there might be a little bit of converting, but not too much of the converting between the two. So let's go ahead and get started. So coterminal angles, they will be coterminal if and only if they share the terminal side. And remember from our previous lesson, we said that the terminal side is where the angle ends. So if I sketch an angle, remember, starting in the positive x-axis and sketching my angle up and over, then the terminal side where that angle lands is this ray that I have that's pointing out into quadrant 2. Okay, so let's say that our green angle that we just created, we'll say that that theta is 140 degrees. It might be a little more, might be a little less, we're just estimating. A coterminal angle shares the same side, so I can travel in the opposite direction to get there. So a coterminal of negative 220 would work, or I could go in the same direction that I originally did, but I can loop around more than once and have a coterminal of 360 one rotation plus the original 40, so 360 plus 140 would give me exactly 500 degrees. So your coterminals, they can be positive, they can be negative, and you can have more than one rotation for coterminal angles. In order to determine coterminals very, very easily, you are going to add or subtract 360 if you are in degrees, add or subtract 2 pi if you are in radians. Okay, if it does help you to sketch your graph so you know where you're looking, you can do that. I'll do that for a couple of them, but not all of them. So for our first example, 105 degrees, that is in quadrant 2, a little bit past 90. If I want a coterminal and I want to go more than one rotation around, I'm going to add 360. So I would have that red angle, which would be 465 degrees. Or if I wanted to go the opposite direction, I would take 105 and subtract 360 degrees to give me the green angle going the opposite way, which is negative 255 degrees. Okay, so there's your visual and algebraically how you determine positive and negative coterminals. So for 310 degrees, we're going to take 310 and add one rotation around to give us 670. There's a positive answer. And I'll take 310 and subtract 360 to go the opposite direction to give us a coterminal angle of negative 50 degrees. We've got two more of these. For 60 degrees, I'm going to go one full rotation in the same direction, so add 360 to give us 420 degrees as a coterminal to 60 degrees. And we will go the opposite direction, 60 minus 360, which gives us negative 300 degrees. And last but not least for our degrees, negative 690, all right, I want to look at that guy, so I'm going negative 360 and then another negative 330 to get me there. So when I take negative 690 and I add 360, in this case it gave me the negative coterminal angle. That landed me back around. I'm going to use this coterminal angle that I just found, negative 330, and add another rotation so that I can find a positive coterminal. My positive coterminal would be that little purple section right here, 30 degrees. Okay, so sometimes you're going to have to add multiple times if your angle is really negative, or you might have to subtract several times if your angle is an extreme positive value. All right, so for pi over 3, remember we are adding or subtracting 2 pi to the radians. So 2 pi over 1 is going to be equivalent to 6 pi over 3. So we are going to take pi over 3 and add 6 pi over 3 to get a coterminal of 7 pi over 3. And then we will subtract pi over 3 minus 6 pi over 3 to give us a coterminal of negative 5 pi over 3. We'll do the same thing for the next one, 5 pi over 3. We're still going to use 6 pi over 3, which is equivalent to 2 pi. So 5 pi over 3 plus 6 pi over 3 gives me a positive coterminal of 11 pi over 3. And 5 pi over 3 minus 6 pi over 3 gives me another coterminal, which is negative pi over 3. All right, our last two examples of our coterminals, negative 11 pi over 4. So I want to take 2 pi over 1 and change it to be 8 pi over 4. So negative 11 pi over 4 plus 2 pi or plus 8 pi over 4 gives me a negative coterminal of negative 3 pi over 4. I'm going to use that like I did in a previous example. I'm going to find a coterminal to negative 3 pi over 4 by adding 8 pi over 4 to it to give me a positive of 5 pi over 4. So now I have a negative and a positive. And the last one, 11 pi over 5, so I need to convert 2 pi over 1 to be 10 pi over 5. So 11 pi over 5 plus 10 pi over 5 gives me 21 pi over 5. And if I subtract 11 pi over 5 minus 10 pi over 5, I get another positive of positive pi over 5. I need to use this one again and subtract one more time. So pi over 5 minus 10 pi over 5 would give me the negative coterminal of negative 9 pi over 5. So I ended up with 2 positive coterminals and 1 negative in that particular example. Reference angles. Reference angles are created by the terminal side, the ending side, of your original angle, theta, and the x-axis. So a couple of things that I always want you to remember about reference angles. Number one, they are the distance that you travel from the x-axis. So I'm always going to be looking above or below just the x-axis. Since it's a distance, and again, we're talking about in angles or we're talking about in radians or in degrees. So since it's a distance, it always has to be positive. So even if you get a negative answer, then you need to give me the positive of that value. And so when we're looking at it, if I go ahead and create, as it says, here's my original angle that I've created. There's my theta. The reference angle, so from the x-axis back up to that angle, is considered your reference angle. So it is your distance that you travel from the x-axis to get back to the terminal side, the ending side of your original angle. Okay, and a couple of things that we're going to jot down as we're going through each quadrant. If you are in quadrant 1, if I sketch an angle in quadrant 1, then the other thing we need to know is that our reference angles are always less than 90 degrees. So in quadrant 1, theta is less than 90 degrees. So whatever my angle is in that quadrant is also the reference angle. We'll use that reference angle to help us get other angles equivalent to it. All right, if we travel to quadrant 2, I've already drawn that guy. So if I travel to quadrant 2, there is my theta, and the reference angle is the distance back. I'm going to do all my little reference angles in red down here. So in order to get that, when we are in quadrant 2, I'm looking at a distance from 180 degrees or pi. So in order to get your reference angle, you're going to take 180 degrees and subtract theta if you're in degrees, or you're going to take pi and subtract theta. Now I'm only discussing these in terms of positive angles, so if it's negative, you're going to do just the opposite of that, okay? So again, if I'm in quadrant 1, that angle represents the reference angle because it's less than 90, it's positive, and it is the distance from the x-axis. In quadrant 2, we are looking at a distance back from 180 degrees or pi, and that will give us our reference angle. If we sketch in quadrant 3, so I'm going to sketch an angle in quadrant 3, there's my original theta. My distance back to the x-axis, I've gone a little bit past, so there's my reference angle. So in quadrant 3, we have to take the original angle that we were given and subtract 180 degrees, or subtract pi if it's in radians. And last but not least, if we sketch an angle all the way around in quadrant 4, here's my original angle. My distance back to or from the x-axis is the reference angle. So here in quadrant 4, we are closest to 360 degrees. So our reference angle in quadrant 4 is always going to be 360 minus theta if you're in degrees, or 2 pi minus theta if you are in radians. And we have several of these that we are going to practice. Some we're going to have to refer back to using coterminals as well. So here we go. Find your reference angle for each of the following. Our first example is 390 degrees. So I want to sketch it so that I know where I land. So one trip around is 360. So there's 360. I need another 30 degrees to get to 390. So my reference angle, this distance back, is 30 degrees. And again, in this case, we didn't really write it down or talk through it, but we just said, hey, I went one rotation around, so I did find a coterminal, and that value gave me the reference angle. 390 minus 360 is 30. That is my distance from our x-axis. In quadrant 2, we have our next example at 100 degrees. So we're looking for our distance back closest to the x-axis is going to be at 180. So in order to find our reference angle, we're going to take 180 degrees, subtract the given amount, and find that the reference angle is 80 degrees. So this little distance that we traveled back from the x-axis to the terminal side of 100 gives us 80 degrees. Alrighty, moving along. Number 13, our next example is negative 110 degrees. So in this case, we're going to travel the opposite direction, start on the positive x, but travel down and around to get us to negative 110 degrees. Again, we're still looking for the closest value that we can get to for our x-axis. So the closest is to go back to 180 or go to negative 180. So if I take 180 degrees and subtract 110, that will give me a difference of 70 degrees, which is my reference angle. There you go. And last but not least, in degrees, we're going 430 degrees, negative 430. So that's over 360. I'm going to go ahead and find a coterminal. So 430 plus 360 gives me negative 70. And we're going to sketch it to see where we land. So starting on the positive x, make one rotation, go another negative 70 degrees to get me a total of negative 430. And so my distance back, the overlap, was negative 70 degrees. So we're going to take the positive of it. Our reference angle is positive 70 degrees. Now our remaining examples are going to be in radians. So we're going to have common denominators in order to possibly do coterminals and figure out which angles that we land in. So I'm going to go ahead. These first two both have a denominator of 18. So I'm going to take pi over 2 and turn that into 9 pi over 18. okay? And then I'm going to take pi and convert that to 18 pi over 18. And then I'll take 3 pi over 2 and convert that, multiply by 9, so it would be 27 pi over 18. And last but not least, 2 pi over 1 is going to be 36 pi over 18. So that's going to help me for each of these examples figure out where we need to land. I'm going to go ahead and label those. 9 pi over 18, 27 pi over 18, 18 pi over 18, 0, and 36 pi over 18. All right, so for the first one, we have 49 pi over 18. That's over 2 pi, so I want to find a coterminal. 49 pi over 18 minus 2 pi, which is 36 pi over 18, would give me 13 pi over 18. So when I sketch, one full rotation is 36 pi over 18. I need to travel another 9 to get me here, and 1, 2, 3, 4 more to get me into this quadrant. So the angle I've drawn does represent 49 pi over 18. The portion that I have in blue is 13 pi over 18. And remember, our reference angle is our distance back from the x-axis we're closest to pi. So in this case, our reference angle, we're going to take pi and subtract 13 pi over 18, because that's what I'm closest to. So 18 pi over 18 minus 13 pi over 18 gives me a reference angle of 5 pi over 18. All right, that one had a lot to it. We had to find a coterminal for 49 pi over 18, get common denominators and convert our radians to all be over 18, and then find a reference angle using that blue coterminal angle of 13 pi over 18. All right, number 36, thank goodness it uses the same denominator. 37 pi over 18 is a teeny bit more than one rotation. So one trip around gives me 36 pi. I need to go one more. So there is 37 pi over 18. When I find its coterminal, 37 pi over 18 minus 36 pi over 18, it does give me 1 pi over 18. That coterminal is also your reference angle. That is your distance back to the x-axis from more than one rotation around. All right, couple more, gang. We're almost done. Number 17 is 19 pi over 18. Find the reference angle. Okay, we've already done the pi over 18s. We got those. So let's sketch that one. Remember, pi is the same thing as 18 pi over 18. So I need to go a little bit past pi. There's 18 pi over 18, 19 pi over 18. So there's 19 pi over 18. What is my distance back to the x-axis, back to pi? So in this case, the reference angle is going to be 19 pi over 18 minus 18 pi over 18. Same answer as last time, pi over 18. And that's totally fine. There's nothing wrong with that. You can get the same answer several places. In our last example, we need to convert all of our radians to be over 4. So let's go ahead. I'm at 0, 2 pi over 4, 4 pi over 4, 6 pi over 4, and 8 pi over 4. And you'll notice we're looking at negative 7 pi over 4. So I'm going to go the opposite direction of everything I just did. So here's negative 2 pi over 4, negative 4 pi over 4, negative 6 pi over 4, negative 7 pi over 4. And my distance back, I'm closest to the x-axis at 0 or 360 degrees, or at 0 or 2 pi, which is 8 pi over 4. So we're going to find, in essence, we're finding a coterminal. 8 pi over 4 minus 7 pi over 4 gives me 1 pi over 4. So our reference angle for our last example is pi over 4. Good job, everyone. Make sure that you practice some of these in the next worksheet in your packet, worksheet B, and have a great day.